What's up, interweb? What we're going to do today is we're going to solve the system of equations by substitution. There's three ways of solving systems of equations, and I'll show you what a system of equation is here in just a second. You can graph them if you have a graphing calculator. Substitution, probably the easiest one, and elimination. And we'll go into elimination next week. If we have a graph and we have a line on the graph, how many points are there on this? There's an infinite number, because remember, the line goes on forever in either direction. There's a point here and a point here and a point here, point here, all the way up and down. There's millions of them. And if you have another equation or another line here, this one also has an infinite number of of points, but there's only one right here that will satisfy both equations, that will equal excuse me, both equations. And that's what we're going to find out here. If we have, well, first of all, let's say is 2 comma 5 a solution, so L-U-T-I-O-N, to the system of equations. Okay. And if we have this, 2x plus y equals 9, and we have x plus 3y equals 17. We put a bracket here to show that it's a system of equations. And remember, this one's x and this one's y. So wherever there's an x, we're going to plug in 2, and y we'll plug in 5. And now we just do order of operation. 2 times 2 is 4, plus 5 is 9. So yes, it works for this one. In other words, this point 2, 5 is on this line. And this one, but for it to be a solution, it has to work for both. If this is a solution to the system of equations, it has to work in both equations, not just one. So we put 2 in for x, 5 in for y. So we have 2 plus 15 does equal 17, so yes, it is. This is a solution to that system of equations. Now, and then you can go on and on, but it's real simple. If it's a solution, again, it must work for both equations, not just one. Okay, now we're going to solve by substitution. S-T-I-T-U-U-T-I-O-N. Solve by substitution. This is real simple. If you're given that 3x plus 5y equals 26, and you're given that y is equal to 2x, system of equations. Now look, y and 2x are the same. They're equal. They're exactly the same. We cannot solve an equation that has two variables in it, two letters. So we have to get rid of one of them somehow. Now we know that y and 2x are identical. Just like a bag of Doritos at Walmart and a bag of Doritos at H-E-B are the same. They're exactly the same. Same thing here. This is Doritos at Walmart. This is Doritos at H-E-B. So we can interchange these two for each other. So in the other equation, we have 3x plus 5 times y. But y is 2x equals 26. Okay, that is that. Now we have one variable, an x here and an x here. So when you get to this part right here, it looks kind of confusing. But if you'll just ask yourself, what can I do? What is possible to do? Well, we can multiply 5 times this. So we get 3x plus 10x, right? 5 times 2x, 10x, is 26. Now what can we do? Combine like terms. So we have 13x's equals 26. Now we have a very simple algebra problem. Divide by 13, x is 2. This is not the solution. The solution is a point, and it's to be written like a point. Now we know what x is. We don't know what y is, though. Now you can plug 2 into either equation. Make it simple. This one's already solved for y, so let's use that one. So y equals 2x, but instead of x, we're going to plug in 2. So y is 2 times 2, so y is 4. So the solution to this is 2, 4. X, y. Right? Right. Now we get a little bit more involved in this, but really not too terribly much. Now what if we have this? X plus 3y. Where am I? Equals a negative 28. And we have y plus 5x equals 0. System of equations. See how pretty I drew that bracket? Yeah. Okay, now we want to solve one of these equations, one or the other, doesn't make any difference, for one of the variables or the other one. Now we could do this one, but the numbers that we're going to end up with are kind of big. So let's do the lower one. Now let's solve it for y. And how do we do that? Subtract 5x from each side. So we know that y equals negative 5x. You can put plus 0 in there, but it really doesn't mean anything. Okay? Now remember, this equation right here and this equation right here are the same. We just rearranged them some. Excuse me, rearranged them some. Now, we know that y is negative 5x. So we're going to plug this back into the other equation. If you put it into here, it's not going to do anything. It's going to be 0 equals 0 or something stupid like that. Okay, so we have x plus 3y, but instead of y, we're going to plug in negative 5x equals negative 28. Now again, when you get to this part right here, it kind of looks confusing, but it's really not. There's really only one thing you can do here, and that's multiply 3 times negative 5x. So we have x minus 15x, okay, 3 times negative 5x, negative 15x, equals, excuse me, negative 28. Now we combine like terms. X minus 15x is negative 14x equals negative 28. Divide by negative 14. Now we know that x is a positive 2. This is not the solution. Remember, the solution is xy. We know what x is. X is 2. Now we have to find out what y is. Now look, this one's already solved for y. Remember this equation up here and this equation are the same, where they're just rearranged, but they're equal to each other. So we know that y equals negative 5 times x. We know that x is 2. So y is negative 10. And that's our solution. Remember, this is to be written like a point, xy. Just like that. Who said math isn't fun? This is good stuff. Okay. Nah, let's not do that. That's stupid. Okay. 3x plus 5y equals 25, and x minus 2y is negative 10. System of equations. Okay, what are you going to solve for here? I wouldn't solve for anything up here. You're going to end up with some godless fractions. Let's solve this bottom equation for x. How do we do that? We add 2y to each side. Now we know that x equals 2y minus 10. And remember, this equation and this equation, they are equal. We just rearranged them some, but it means the same thing. Now we take this, x is 2y minus 10, and plug it into the other equation. So we get 3x. Now how much is x? 2y minus 10. Okay, plus 5y equals 25. Now again, there's really only one thing you can do here, and that is to multiply 3 times everything in here, and we get 6y minus 30 plus 5y equals 25. This is a y here. Now we only have one variable in here, and that's what we need. We can solve an equation that has one variable. We cannot solve an equation that has two variables in it. Okay, now we combine like terms. 6y and 5y is 11y minus 30 equals 25. Add 30 to each side. Okay, that's gone. So we have 11y equals 55. Damn it, I've got a mosquito in. I hate mosquitoes. Worse than Yankees. Okay. 11y is 55. Now to solve for y, we divide by 11. So y is 5. And again, that's not our answer. Now, again, this one's already solved. This equation down here and this one are the same. So we're going to plug in 5 in here for y, and then we'll solve for x. X equals 2 times y. Y is 5 minus 10. So this is 10 minus 10. So our x is 0. Can we have 0 for an answer here? You betcha. 0, 5, if you were to graph it, would be right there. So our answer here is 0, 5 in parentheses, and like that. And that's basically all there is to it. It's really very simple. Just don't let yourself get overwhelmed when you get to this part right here, because you look at it and think, oh my God, I can't do this. Well, you can. It's all real simple. It's stuff that we've done all semester. So just kind of go with it there. All right, y'all take care. Bye-bye. Have a good weekend. Bye, Bonds.